for this work. So we're going to be talking about benchmarking and operational achievements at Willis Tower. Hopefully you come away from this presentation with at least understanding why Energy Star benchmarking can be so important to a project, regardless of the end goals or what they may be driving to do. Other strategies for improving building operations, even with massive engineering staff, preparing accountant deficiencies, and applying these lessons with other buildings. So Willis Tower. So once upon a time, a building owner, property management team was told no. They were told that it can't be done, that Energy Star benchmarking, at least a certification, was not possible. It's too big, it's too old, uses too much energy, it's not going to happen. LEED certification, too big, too old, too many meters, not possible. Too many cats to herd, not possible. Well, we said, hold my beer. We went to work. So 4.5 million square feet, 1,400 feet tall, 110 towers or floors. It's the second tallest building in the US, 12th tallest in the world. So we had some work on our hands. And that's really where this overall story begins, is trying to find the opportunities where others were not able to, digging into the data, the utility analysis, and finding the path towards an Energy Star certification, towards a LEED certification. So take a step up to 1,300 feet, and they have the highest observation deck through the sky deck at, what is it, 100 and some floors up there, but 1,300 feet, it's high. This is photo courtesy of our coworker Megan. I hate heights, so they had to pull me back by the shirt to get me out there, and I did not look down. Thankfully, it was very foggy. You couldn't see the ground when we went out there, but she got a nice pic of this. So it takes a lot of work to keep 4.5 million square feet of building humming on a regular basis, all while undergoing a $500 million facelift. So you'll see a picture of that a little bit later on in this, but $500 million. So what does that get you? It gets you about 300,000 square feet of 5 floors of retail, new entertainment, floor, roof deck area, park setting at Willis Tower, downtown Chicago. Thankfully, the owners also had a focus for improving the building operations, not just the aesthetics of the facility. And they incorporated new automation systems, higher efficiency lighting, controls, improvement to the exhaust system and the dampers. As you can imagine, stack effect is pretty significant in 1,400 feet. New filtration or new filters for the air handling system, so like updating things to MERV 13s, those types of things as indoor air quality becomes more of a hot topic these days. VFDs, chiller modernization, and then ultimately to handling and improving the electrical systems. So you don't always have to do all of those things to achieve a LEED certification. They just happened to do so and wanted the marketing benefit of what they could sell and market to prospective tenants through a LEED certification. So real quick, the LEED Gold was achieved under the version 2009 and simultaneously under the newest version under V4.1. So we did those at the same time, little extra work to get the V4.1 documentation done. But we had to start somewhere. And that first spot was benchmarking the facility, getting a grasp on about 150 electrical meters and a whole bunch of other utilities that we needed to get a better understanding on that weren't really ever understood. How many meters, what do they serve? Are they valid for the Energy Star benchmarking? Can we exclude them from the analysis? We had to work hand in hand with EPA. We had to work hand in hand with the USGBC to make sure that the path and the process that we were moving through was actually going to be a viable, end in a viable certification, and not we weren't just spinning our wheels. So how many people have benchmarked a building in Energy Star before? Okay, so not many. So hopefully this at least encourages you to go check out Energy Star Portfolio Manager when we're done here. Whether your scope is an energy audit or building commissioning, Energy Star benchmarking should be a part of every conversation. So basics of Energy Star is space types, square footages, operating hours, occupant counts. Occupant counts, this was an interesting one. In this building, there's just shy of 18,000 opinions on a daily basis. 18,000 people potentially complaining about too hot, too cold, there's a draft, there's this, that, or the other thing. There's a water leak or whatever it may be. But 18,000 opinions alone is a lot to handle. So we had to get a grasp on that. We had to work with a lot of the building tenants. Right now, I think they're about 94% occupied. So they're up there. They have that space pretty much built out. Yes, there are still square areas that are under construction and those types of things. Rick will touch on some of those notes a bit more later. So once we grasp all of that, 4.5 million square feet, it's about 17,800, 900 occupants, not including the visitors every day. So that increases that a lot more too with their sky deck and all. But we knew that once we had all that stuff collected, we had an accurate Energy Star build, but they still had a low score. So what could that possibly be due to? And Rick is going to start with some of the building operational things that we went through for the project.
Thanks, Rock. Okay, so that might seem like a quick jump from benchmarking to building operations. When we talk about benchmarking, first off, we want to try and get that score accurate, and then we want to take and start building their operational documents so we can look at the building. With that low score, we needed to go in and try and find some energy. Why were they using so much energy that had an impact on Energy Star? So we start off with our best practices operational documents. One, this is required for LEED certification for EAP1, and this turns into the basis for an ASHRAE level 2 as well. So just of the commissioning folks in the room, when you go in to do a retro commissioning or an existing building, how many of you get these documents? 1, 2, yeah, that's, it often requires a lot of research, really interviewing the staff, because things like the systems narrative and the sequence operation, sometimes that's knowledge that's built in, just in the system and in the people who work there. This building, we had 3 people who started there as apprentices 40 years ago when the building opened, and they'll probably retire out of this building. So quickly, building operating plan. That's going to tell us what the occupied cycle is for the building, when people are in the building and when the equipment should run. Systems narrative is going to give us a description of the systems in the building, mechanical, lighting, domestic hot water, and then the controls for those systems as well. Sequence operation is pretty straightforward, but sometimes it's difficult to come by. And then finally, building drawings. We're starting out with 40-year-old drawings. You want to compile these all together as a basis for their operations manual to be right there next to their workstation. First up is the building operating plan. This really provides the occupancy conditions for the building. Like it says, hours of operation, the schedule of when the tenants are going to be there. What are we trying to maintain for space temperature and humidity? What are we trying to maintain for lighting levels in the space? This is based on often the leasing documents as well. That helps us to align our mechanical equipment runtime to meet these occupancy conditions. So if you have occupants in the building from 7 to 4, you want your mechanical equipment to run as close to that 7 to 4 as possible to be efficient. This also helps to align our building's operations team and the management team with the tenants in the building. This tells them, when tenants are going to be in what spaces, so they are more responsive to that. Per LEED requirement, this building operating plan is organized to align with the Energy Star profile. So Energy Star, when you go in, you'll see items like occupied office, vacant space, parking, data closets. and square footages. Now, that's fine for the LEED certification. When I'm working with teams, I like to tell them, arrange a building operating plan by what makes most sense. Does it make sense to arrange it by your tenants? Does it make most sense to arrange it by floor or even by mechanical system division? So we have our building operating plan that tells us when the building is occupied, what we're trying to do in those spaces. Next, we've got our systems narrative. So the systems narrative is really a description of those mechanical systems, lighting, and domestic hot water that meet your conditions defined in the building operating plan. Additionally, the systems narrative is organized just like the building operating plan to meet that LEED requirement, and so it matches and makes sense to what you're reading. So in the systems narrative, what we give is a description of all these various systems: the space heating, space cooling, ventilation, lighting, domestic hot water. An example of what you would see is for space cooling, the source is the chiller. The chiller provides chilled water via insulated piping to the chilled water coil in the air handling unit. The chilled water coil provides exchange to absorb heat from the airstream, and the chiller will reject heat via the cooling tower. This includes equipment labels, locations if you like. On ventilation, this would describe how are we bringing outside air into the building. Is it through dampers at air handling units? Is it a fan system specifically devoted to outside air? And this is once again repeated for each of the functional areas. Also, you'll have lighting. So for lighting, we're looking at what kind of fixtures do we have? What kind of light bulbs? Are we LEDs? Are we fluorescents? Then you have domestic hot water. What we recommend here is, what's your production system for domestic hot water? Is it heat exchangers? Is it gas hot water heaters? Is it electric? Then where are they located within the building? We really try to make this a useful document so that once we're done with the certification, they don't just throw it in a folder somewhere and forget about it. Then you have your control systems. Information that would be good here is manufacturer, date of installation, locations of items like equipment panels, operator workstations, and then any user information as well. Maybe if it's on a web browser, what's the browser address to hit that building automation system graphics. Lighting systems as well. Do you have a lighting panel? Do you have software? Oftentimes, you'll have a separate software system for the lighting control as for the HVAC, and it may be on a different computer. So that just kind of follows up. So you want that to match your building operating plan. You're also going to have some assignments to who is filling out these documents between the building operating plan and the systems narrative, who is reviewing them. We really should review and update these systems, on at least a yearly basis. If the Energy Star changes, that may change your hours of operation if you get new tenants, if you're putting in new equipment. Additionally, here, and it's not listed, what's good to include is tenant equipment. Are your tenants including adding in split systems for computer rooms and the like? Final item in these three kind of written documents is your sequence of operation. So this is describing those systems in the systems narrative, how they operate to meet your building operating plan. This starts with the as-built drawings from when your systems are installed, and it should be modified on a regular basis to include updates to the mechanical equipment, changes to your sequence of operation, and then if you have tenant modifications to the systems as well. So if you have tenant improvements and they add it or build it out, that should be included. Now, the sequence of operation can be a challenging document to keep updated because generally it's easy to modify the sequence of operation without going back to that source file or source documentation to update that. Final item is the building drawings. So building drawings, you start with a decent set of as-builts at building occupancy date. Then you try and keep those up to date. So If you are getting mechanical equipment updates, if you're replacing cooling towers, pumps, that should be noted in your drawings. If you have tenant improvements, they're going to modify the mechanical systems on the floor. That should be rolled into the set as well. And finally, if you're in an older building and you don't have hard copies of that building documentation, or sorry, if you do have a hard copy, we really want to try and get that electronically, whether it's scanned or you contact those original design firms to get their AutoCAD files over to PDF. So we've assembled these documents. What are we going to do with them? First thing we're going to do is we're going to upload as part of the lead submission, because that's a requirement. We're going to share these with the operations team, because they may not have these documents and they may not be up to date. And then the final thing, we're going to use these docs as a tool for going through and evaluating the mechanical systems in the building, the lighting, and the domestic hot water. First thing we're going to start with in that evaluation, and this holds true of any project and Willis as well, is looking at the building automation system. This is where the operators are going to interface, and a lot of times this is where it'll be very easy to find improvements and see issues. We'll look at things like the building automation system health. When was it installed? Has it reached end of life? Is it up to date on software updates? What do they have for a server? How old is that server? Same thing with their operator workstation. In the case of Willis, you'll see it was somewhat of a precarious situation with their building automation system. Then we move from there and we can look at possible issues. So nuisance alarms. If I sit down at an operator workstation and there's 500 alarms that haven't been answered, then that tells me that they're not using this operator workstation. They could be missing information. Do we have overridden system points? Are they overriding schedules? Are they overriding set points? Are they overriding equipment points on and off? What this tells me is they may be trying to compensate for some issue in the system by overriding that information, and the system's not operating in a full automatic and giving them the most value. Then this also kind of touches on operator training gaps. Are the operating team fully aware of what the system can do? You get new guys coming in, you get old guys moving on. Maybe they haven't been trained, or they just kind of acquired it from sitting down and working at the machine. Then we can start to use building automation system to identify these low cost, no cost energy conservation measures that are important to saving energy and saving it quickly. First is using the schedules to reduce equipment run times. We want to get our schedules as closely aligned with that building operating plan as possible. Look at our set points. What are we doing with our space set points at our terminal units? What are we doing with our set points at the major equipment? Are we employing set point reset? Are we limiting those set points so we're not getting absurd values? And are we operating within the parameters of your building operating plan? Then we can look at some more advanced sequence of operation changes to try and save energy. Are we employing optimum start? Are we employing morning warm up and cool down so we're not over ventilating the building prior to our tenant occupancy? So this is what we found when we looked at the automation system. We had an existing system that was old in 1998, and it was sitting on a Windows 98 laptop, a rather dusty laptop, and it was kind of scary. So we had that system as the base building. Then we had some tenant improvements, and those tenant updates were operating on a new train automation system. So they had two workstations that were very different. One operating on, a system that was almost DOS. The next thing we saw is that the operations team is very hands-on with the building automation system. So they're essentially using it like a time clock. They are changing the schedules on a nearly daily basis. They're changing the set points on a daily basis. They're doing that to account for building conditions, outdoor air conditions as they change, and then building schedules as they change from day to day. This is something we really want to see them get away from. And as Rock mentioned, there is a building automation project that started right at the end of our certification. And my hope is that we go back there in the next recertification and we see that the system is in automatic. We've gotten away from that time clock. They're really using it to optimize the building operation. As I mentioned here, they do have an ongoing project to upgrade that base building automation system and get an up-to-date sequence of operation and automatic control doing what it should do. Also, an additional item, we've got ongoing tenant improvements which do impact that building automation system. We have a lot of existing legacy systems on the floors, including all the way back to pneumatics. So as those get added and brought in, it has an impact on the function of the building automation system, and that needs to be taken into account during those projects. All right, so we looked at the building automation system. Our next step was to conduct a night audit. So we take our documents, we use those as a basis of looking at the systems. What we're doing during the night audit is we're looking for mechanical systems while they're off. We can climb into an air handling unit and look at the ductwork, see the state of it, look at filters, are they being changed, motors, belts. Is there equipment that is manually overridden in hand at the unit? Is there other equipment that's running when it shouldn't? What are the spaces doing? Are the lights on or off when it's unoccupied? And what are the levels of that lighting? Additionally, to go back to the Energy Star benchmarking, we're looking for any large energy consumers. With a low score, they're using a lot of energy. What is it? Is there anything obvious? So here's what we found when we looked at the after-hours operation of the building. We saw often that unoccupied spaces were lit and they were conditioned to occupied levels. Vacant spaces, and by vacant spaces, I mean spaces which have been demoed and are completely open, no tenants, were used as a space to dump air during after-hours operation. So the way the building is divided, you may have one floor that is looking for conditioned air after hours, but the mechanical equipment lacks the ability to reduce capacity for that single floor. So they would just open the dampers and dump air. You'd walk into a vacant space with 68 degrees or 65 degrees space temperature, and the dampers would be wide open on that floor. As we walked around the tenant spaces, the newer spaces did have a lot of items like lighting control, newer controls. Some of the issues we saw there were tenant television sets remaining on during unoccupied hours, computer room equipment on continuously, coffee makers. So we're talking about those Bunn commercial coffee makers that you walk up, you hit the button, you've got a cup of hot coffee or a thermos of hot coffee instantaneously. So we found that these are 1.5 kW to 1.8 kW each. And when you're talking about 100 plus stories, it can be a significant amount of money. Does anybody care to guess how much money? You don't get a guess. Price is Right. How much money, is this going to save them if they turn these units completely off during the unoccupied hours? $83,000 in that building. If they went to, if they turn these off or put a time clock on the wall, if you turn those off, somebody's there after hours, they can use a Keurig. But it's a significant amount of money. Another example, in those construction spaces, in those vacant spaces, things like blinds and shades weren't drawn. If you have a vacant space, draw the blinds, it's going to reduce your cooling load. So these are, typical items, but there's some things we see as we go through the building. One, there were very few low-cost and no-cost ECMs. They were really on the schedules. They were on the set points as much as they could. What they could change, they had. What they tried to optimize, they could with the systems they had. We saw very few issues with the MEP systems. So we didn't see many issues with the belts on the units. Dampers operated well. And filters were changed on a very regular basis. Ductwork was in fairly good condition for a 40-year-old building. And then the other thing we found is that Willis Tower, there are no low-cost ECMs. So on this project, they had set a limit of $5,000. Below $5,000, an energy conservation measure was considered low cost. Above it, it's considered a capital improvement. given the scale of the building, everything is a capital improvement. To make modifications to the building automation system, you've got a guy coming out for 80 hours due to the age and due to some of the factors there. The other thing we found or didn't find were these these large energy consumers. We didn't see a lot of electric heaters. We didn't see overly inefficient lighting systems. They weren't running equipment just to run it. So we kind of had to draw back out and take a new approach.
All right, so real quick, we'll just kind of talk about the building documentation. So how many people have created that building documentation, the building operating plan systems narrative sequence of operations for their facilities? All right, we're getting closer to 100%, so I'm almost done having to talk about this when I'm presenting on things. So keep it up, keep it up. So one of the biggest issues that we found in the benchmarking process for this building was the energy profile wasn't matching what we were actually seeing on site. There weren't these, blatant, operational concerns. They had things under control. They were knowledgeable. If we found something as we were walking through with one of their staff, they were on the phone to the, central mechanical room, and they had a work order scheduled immediately, and immediately also had somebody working to address it. So there weren't those concerns. But why was an office building using about 50% of their energy during the day and 50% overnight? Well, it happened to be something that was right above our heads the whole time. Those are 300-foot antennas for broadcasting. And there's about 50 or so major transformers and meters located here. That broadcast equipment runs 24/7 and consumes a mass ton of energy. Well, when we were looking to get this building Energy Star certified, we're like, well, how do we handle that type of load, which is very atypical for your average office building? So that's why having the conversations with the building staff, with the third-party certifiers that were going to be participating on the project, which was Energy Star, so the EPA, and then the USGBC for the LEED certification, we had to be like, okay, what do we do? We want this building to be able to get those certifications. It's a big win for Energy Star. It'd be a big win for the USGBC to have Willis Tower, pursuing these certifications. So everyone was invested in finding a solution. And what we ended up identifying is that we could exclude that one floor of transformers and meters and that associated energy use, because it had zero impact on the rest of the actual focus of the facility, which was an office building. So once we removed that, the energy profile really made sense. And the KBTUs, all of those things fell in line with what a typical office building was actually consuming or should be expected to consume. And we were able to get Energy Star certification for the largest building ever. So it was a good win, but it's something as simple as the 300-foot elephant in the room to really be able to drive that certification process and those conversations of figuring out, okay, slowly stepping through, finding the documentation, and working through that process. So Rick's going to account for some of the other deficiencies, or in this case, the lack thereof.
Thanks. Okay, thanks. So we threw this slide in here, and on a typical, and this is why, on a typical building, I walked through that process that we just went through, and we find a lot of issues. We find deferred maintenance. We find a lot of points overridden, even if they have a good building automation system. And that's a good way to start saving energy. We really didn't have it here. These guys are really on their ball, or on their game, excuse me. So now we're going to switch gears a little bit. We're going to talk about ventilation and outside air. This actually is what we consider part of the benchmarking of the building. You're looking at, we've talked about energy. What's the building doing? What should it do? Now we're talking about more the human environment. What is the building doing? What should it do for that human environment? First reason we do this, it's required by LEED. It is required by LEED that you go through and you identify the outside air needs, the ventilation needs of the occupants of the building based on the usage, and verify that the mechanical systems are doing that. This also has an impact on the energy consumption of the building as well. If we need to bring in more outside air, that's going to require more conditioning, it's going to require more tempering, and in the end, it's going to require more energy. Now, sometimes we have good news, and they're bringing in too much outside air, and then we can reduce that. So with Willis Tower, first off, they're not monitoring their outside air intake at all. They have, on a lot of the air handling equipment, they have devoted minimum OA dampers. They just go open to a percentage. So what we did was we took a couple of steps to this, because it's a building with 35, in the end, 35 large air handling units that we had to go through and take readings on to verify the ventilation rates. First step was to create a schedule of the units, look at the dampers, and look at what they should be bringing in for outside air. Then we took a survey of the building. We visited the air handling units. We compared what's there to what we had from the original drawings and the original mechanical schedules, because that really was the latest documents we had. We tried to identify any issues going on with the dampers on the air handlers, with any of the ventilation equipment prior to those readings. So as we send our T&B crew in, we want to make sure that they come to systems that are operating properly and the in-house staff has already corrected that. Finally, we do the survey to document any changes that have occurred over time. So between 1973 and 2018, what we found is that they have removed or decommissioned 23 air handling units that we would have been trying to find readings for. These are mostly due to changes in space type, removal of retail areas, and some of it was done to the initial construction phases of the building. So hand in hand with that ventilation is the critical zone survey of the building and indoor air quality survey of the building. So critical zones, we're looking for those high density areas where people congregate, which are going to drive based on the ventilation calculators. We're going to drive your ventilation rates. And LEED also requires you perform IAQ audit as well to determine, what are the conditions in the space. What this required was that we walk the building. So we walked the building to document conference rooms, document large gathering areas and dining spaces, also take multiple IAQ readings per floor over 4.5 million square feet of building. It took us about 5 days of walking the building with one of the staff, with one of their in-house engineers, and really hitting every floor. So we did this, as we say, to document the changes. It was a single tenant in 1973 with 1973 level technology. We're now 2018. You've got a gymnasium on the 37th floor. You've got a couple of restaurants. You have all these changes that have occurred, and we need to catch that for the ventilation. The other kind of unwritten aspect of the survey is you're walking around with an engineer and you have firsthand interactions with the building occupants. If they have complaints about it's hot or cold, they're going to tell you. And that's the first indicator that there may be an issue in that space. Also, when you're walking around with an IAQ device that's making noise and is buzzing, they're going to ask you what you're up to. So after all is said and done, what we found is that this building is a healthy building. They were meeting their ventilation rates, and their indoor air quality levels were quite good. When you're looking at CO2, total VOCs, it was a good space to work in, even given the age and all the other considerations. All right, so I'm going to hand it back over to Rock.
Thanks, Rick. So applying the lessons that hopefully you'll take away from this includes, what do you do to prepare for tomorrow? So in Willis Tower's case, they're spending $500 million for tomorrow. which above, that's what is currently there. And tomorrow, $500 million later, will get you about 300,000 square feet, 5 floors of new retail tenant occupant gathering space, a new automation system, updated HVAC equipment. Part of that process is Energy Star benchmarking, LEED certifications, in this case simultaneous in 2009 and V4.1. And really to kind of wrap this all up to a point of the LEED part was only $400 million of the total project. Just kidding. It was less than 0.1%. So when people say, oh yeah, LEED costs more, it costs some, but not as much as you'd expect. So preparing for the change of what tomorrow may bring. Benchmark now. So Energy Star benchmarking was a key focus for this one, not just for what I would have hoped their hopes and dreams would be of an Energy Star certification or LEED certification, but really to understand what the value of the projects that they were doing were going to actually have on their facility. Were they going to see the automation system drive energy savings for their facility? Well, they would not really be able to tell specifically in any sort of, okay, we have 150 electrical meters for this project. Well, which ones are we seeing reductions in? Why? Well, now we can narrow that down and say, well, we know we have the automation system implemented on these floors or controlling these units, and we know what meters are associated with those floors and that equipment. So now we can focus there, and we can see that the impacts and the investment that we're making is truly paying off. So that's why Energy Star benchmarking, whether it's a commissioning project or for work and different types of scope, is so very important for these types of projects. The occupancy and operations. So today, almost 18,000 opinions. What's tomorrow going to be? What's the new 300,000 square foot going to require from an occupancy and operations standpoint? What are we doing from updating the building operating plan, the systems narratives, the new sequences? How is it all relating and working in the building together? So that's part of the truly automating the system and kind of taking away some of the control from the operators. Remember, there was at least 3 of them that started there as interns or apprentices, and they're 40 plus years into the building. What happens when those guys leave? Who's next? Yes, they're training people every day, but that knowledge is going to take some time. Those documents are the basis of okay, study these. At least now you have a decent grasp on where things are, how things operate, and how this equipment and this building functions, because it is atypical from your typical suburban office facility. And then again, all the meters, so over $7 million of annual electrical spend, 100 million kilowatt hours a year in electrical usage. So you're managing a lot of energy, and it's important to have a grasp on that. So again, keeping track, build best practices for documentation until this becomes a standard practice. We'll continue talking about it. Energy Star, just get their benchmarking done. The new platform for LEED V4.1 for the performance path, all buildings in, get those things documented and start tracking this. It helps. All right, questions?
When you said you didn't find any outside, they weren't over ventilating. I find that almost impossible to believe from a building that was designed for a code from 1973. Is it because they took 23 air handlers offline that you think it was close to what 2018 code would say?
I think part of the reason is that, yeah, and then part of the reason is they really ran those minimum OA dampers at a very minimal level to try and they were cognizant of it and just trying to reduce it. I think the dynamics of the building is such that they were getting enough outside air. With that new automation system, I'd love to go back to this building in 5 years, and if they have outside airflow metered, if they're doing a better job of monitoring pressure in the building, what's it really doing then?
Yeah, with the balancing work that they did there as well, that helped. Chicago has a pretty stringent outdoor air requirement, more than what is typical. in other cities. So all of those things, they were at those levels. So it wasn't it may be over ventilating in, say, Milwaukee, where we're from, or versus like Chicago and their requirements. So it's just really dependent on some of the local codes and what they're able to tune.
You know, they're I hate to put it this way, it's pure luck that they're ventilating properly.
Yeah.
Any other questions?
So initially we started in the mid-50s. We peaked at about 78 and immediately went through the certification labeling process. And then with the new Energy Star update in August of last year, they dropped back down below the certification potential. So as it hit everybody, it hit them as well. So their ongoing continuous work to just, okay, find more ways to save energy.
Instead of using the building asset score?
We have on other projects. We have not used it on this one.
The good thing about that is that you can have a really great engineering staff and they're good with chewing gum and they keep this building operating phenomenally. The equipment is really crappy.
Yeah.
And then you get a really good building with a crappy engineering
Yep.
team, and they still get the same Energy Star score.
Yeah.
And that's where the asset score kind of.
It's very good at that. The benefit here was more in that the recognition through the Energy Star focus alone. So that's where we targeted. It would be for the other projects that we've used the DOE, asset rating program on. It does provide some good insight into, okay, what's operational impacted or operations impacting versus what their ability would be.
We just started to use both. That's why.
Yeah.
Yeah, I really wish we could have used it on this project. You've got a really good engineering staff, and up until recently, they've been, keeping the building going because the previous ownership teams have not put that money in that now you see Blackstone doing.
Yeah. Anybody know what these pods are? No, I guess? Those are for the window washers.
Those are the garages for the window washing robots.
They're fairly large. They have the nice little storage place in the winter, and they just slide out, drop down, and are continuously cleaning that building.
Strictly as an aside, we're in Milwaukee, so we're close to Chicago, and I grew up in Illinois. Our team, when we go into this building, are like geeks. We're like little kids running around. There's a lot of, when the building was built, there was a lot of innovation. There's a lot of quality that went into it. And you see that now and you hear about it. And it's amazing. It's really something to experience.
Any other questions?
Hey, just out of curiosity, when you guys were talking about the coffee makers, I thought that was quite interesting. Did you also look at other, like when you say the number of opinions that are in that building, did you guys also take a look at other plug loads?
We didn't directly.
If we looked at other plug loads and all
we
that
look
stuff,
at other plug loads
besides coffee
makers. We didn't directly look at plug loads. It was a lot of anecdotal what we saw because, with that night audit, we were really looking for something bigger. We were trying to find a way to drop that Energy Star score. So, for example, the coffee makers, that's $84,000 a year. On an Energy Star score on that building, wouldn't move the needle.
Yeah, $83,000 dollars, and then the investment of installing a time clock on each one of those or something like that. The cost is like, okay, we can do it, but we're not going to anger the tenants. So it's just an example of like, even though there's $83,000 in savings sitting right there, the investment versus the risk of angering the tenants was one that they were hesitant to do. So we had the conversations with each of the tenants. We haven't gone back through to say, okay, now how many did, so what are your actual savings and those types of things. But we, through an educational session, so all of these parts and pieces, we have it can't really be done without a proper tenant education, I guess initiative. So it's the newsletters, it's signage in the elevators saying, this is what we're trying to do here, help us out. And these are some of the recommendations that you could potentially try to do in your space or try to influence in your space. So it's working with the tenant contacts and those types of things. As we're walking through their spaces, doing all these testing, it's great to be able to come back to them and say, yeah, you're really getting what you're paying for here. Buildings running properly, they're not wasting your money through excess energy usage. They're doing plumbing retrofits to make sure to bring down their water costs. This is the carbon emissions, the thing that you have proper indoor air quality. These are the things that more educated tenants are now asking, at least at the initial, brokering phases. So back to the plug load question, yes, there's TVs, yes, there's coffee makers, printers are on, they have refrigerators that are still plugged in on vacant spaces. The computer's not in, sleep mode or with a night mode on, those types of things. But the tenant education aspect, we're trying to influence it that way.
No managed breakers were thought about.
Not at this point.
Yeah.
They're still, they're behind in a lot of ways, and they're working to catch up. So that'll be one of their future upgrades, especially when it comes to lighting and plug loads. Yeah.
For example, they have their typical office, space equipment, the general HVAC, and then they have certain tenants that are like, we want to put in chilled beams. Okay, let's figure that out, how to incorporate that on one floor for one tenant. But if you have a big enough tenant and they're willing to pay for it, why not?
And it's also a test bed.
Yeah.
So on future tenants, they can look at the chilled beam system and go, okay, this makes sense. We can then develop this as a standard across all our tenants. Mm-hmm. Or it doesn't work given the systems we have. It's not the most efficient way.
And with 110 samples of different systems and different operations, different tenant usage, you can play with a lot of stuff and test a lot of things and set standards then for your occupants moving forward. Yep.
All right, thanks.
Cool.
Thanks for
Thanks,
coming in,
everyone.
guys.